Thank you so much, and really nice to be invited to talk here at AWE. So I will take you on a 3D visualization and spatial computing journey at IKEA. But first start, I hope everybody knows what IKEA is. Yeah, I guess so. The IKEA vision is to create a better everyday life for the many people. It's nothing actually in that vision that we should sell furniture. But we are doing that by doing well-designed, functional home furnishing products and making them so as many people as possible can afford them. But giving you some sense of scale, we had a turnover last year of about 48 billion euros. We sell about 75% online. 25% online, 75% in the stores. We have about 220,000 employees in the world. And last year, we opened 71 new physical locations, still doing that. But you're not so interested in IKEA's vision, probably, and maybe not the company profile. You're more interested in the 3D journey. And the 3D journey really started with this equation. This is the render equation. And we have been using that to create these. That's the whole idea. That's really what it's been all about. And it started back in 2006 when we produced this little product there. It's Spatial, it's the chair. And that was the only thing for a year. And then we continued. In 2006, that was it. In 2009, we did the first room. In 2016, we started doing animations and film and mixing it. And in 2015, we ourselves were talking about large-scale production. So it took us some time. And just to make that note now, everything I show on screen now is computer-made, just so you know. So when we talk about large-scale production, it's these kind of things. And the thing that made it hard for us to do this is that we didn't stop doing photography. We actually do these in combination with photography. And what you also see on these kind of pictures is that we have to have a lot of products or things that we don't sell. We have to make them in 3D too. That means that we also have to do food. We need to fill out drawers with things that we don't sell. And this is to prove and show the function of things. So food on plates needs to be there too. But this is just to give you an idea on what we did. To be able to do this, we started to do a big project internally in 2009, and that was to build a 3D model bank of things. And at the same time, we were also cross-training photographers and 3D artists. But this thing then contains a lot of stuff. Except for bread that you see on screen, we have all our products in here. There's about 60,000 high-res 3D models of our stuff. We are storing them in here, and then we are having all the materials or all the surface appearances. We store them separately. And the reason why we do that is that we don't want to put them on the actual object by themselves. An oak number one is maybe on 300, 400 products. And updating that takes a lot of time. But then when we have it like this, we can also search for which product has a certain material, and then we can find that backwards. We also have textures and so on separated from the actual materials, also to reuse. And our textures are really, really large. Like 30K is a normal one, 30K, 10K in 16-bit precision. And so we are doing it in very high scale, on high resolution. And this we started doing in 2009. We were ready in 2012. And we skipped a lot of products. And we skipped these. We started doing them 5, 6 years ago. So hairy things, textiles, those kind of stuff, that is hard. Unfortunately for me, who works with 3D graphics, IKEA sells a lot of different things. We even sell these. And we make them in 3D too. Of course we have to. And that means that we have to figure out how to fold towels. We have to figure out how to grow plants. We have to figure out how to groom hair on small toys to be able to build all the assets we need to have for all the products we need to do. And we do them in really high resolution so we can handle a long-term life, and I'll come back to that a little bit later. But that also means that we have to render these things, and render them takes a lot of time and effort. So we have a render farm, about 3,500 CPU cores. We can't really use GPUs because our textures are too large, so the GPUs have been too small. Then we give even more power to our artists. But that means that during the lunch or the evenings, we have a render capacity of all of this, about 7,000 or almost 8,000 cores. This works nicely for us. We render almost everything with this. We also do all the rendering real-time 3D model conversion on the same pipeline. So it's the same pipeline running both of these things. Then we also have a safety. The safety is called cloud. So we have an on-demand render capacity in the cloud that we can turn on and off. We don't use it that often. But to have it up and running, we have about 6 million assets synced online. So this is what we're using it for. We are making still pictures. We are making animations like this. And the real reason is that our products have a function. And that function we need to show. And the same product can have different functions. That means that we have to show it in different places, move it around in spaces, and show it with a lot of different things in it, because that's what makes sense in this world. So that's the JPEG, or animation production, that took us about 10 years to do. At the same time, we were adding the augmented reality stuff in 2012. We used the catalog as a marker. We printed about 200 million of them and gave them out. So why not use it as a marker for AR? And we did that for 5 years, between 2012 until 2017. And then in 2017, we skipped the catalog and used AR Core and AR Kit instead. And in 2016, we actually did our first XR or VR thing and put it on Steam. I don't know if anyone in here has played the Meatball Kitchen kind of thing that we did back in the days. Yeah, a few of you. It was one of the earliest things. It was my team making that. It was really fun. So things are progressing since then. If we are adding the latest years, we have been taking all our planning or 3D editor tools that is online on the website and put them all in 3D. The kitchen planning tools has always been three-dimensional, so it's been there since 2001. And if you look at this, you can say that the use of 3D has been steadily going up. Internal use, external use, the actual use of 3D all the way since 2005 and that first Bertil share in the catalog that wasn't bigger than a stamp. And the latest addition is that we have added it on our product information page. And it looks like this. It's a small little button there, and then you can, of course, spin it. You can see the files and everything. And, of course, you can go to an AR version natively on the phone if you have a phone. This, for this audience, is probably very, very basic, but it's there, and it's web-based, and it's for all the products. But the thing that is interesting in working for a company like IKEA, especially for me, is that we have to do everything in scale. That means that we have to have everything from product development as a fully connected pipeline. And if you look at the green arrow, that should be easy. I see some people laughing. It's not easy. Even if it's coming from CAD, even if it is 3D, even if it's done that way, it's still hard to make this work. Then you have the lower thing there, where you have plants and toys and textile stuff. That's even harder. And we have about 50-50 of our products having hard surface things like you can get from a solid modeling thing to the ones that you have in the lower path. And sometimes they are mixed together in the same actual product. But we try to go to one really physically correct 3D asset and then go from that one down to the different use cases, sometimes using it as it is, but very often going in down and compressing it down in GLTF, USD, or whatever, for different render engines to use that in different solutions. Since 2009, we have made 3 different levels of details on our products. The most high-res one is down to 0.2 millimeters. That's 5,000 definitions per meter, if that helps. And down to 1 centimeter accuracy. And this is to be able to use the same kind of asset for different use cases. The last 5 years, we have actually gone up to 4 times this. So we are at 20,000 definitions per meter, or 0.05 millimeters accuracy. And this is to be able to handle the human eye max, the retina display, or 60 pixels per degree that you can handle in a way in your eye. I will come back to that also a little bit later. The thing that we have to think about, fortunately or unfortunately, I don't know, is that we have a lot of products that has a really long life, even some that people know by name, like Billy. But this is the Poeng share, and it's designed in 1978. We built the first 3D model of it somewhere in 2011. We can still load that and use it in our production. That's over 10 years of technical development, and it still works. So how do you define something today that you load on the other side of 2035? It's almost impossible, of course, if you don't have a crystal ball, if you can't look into the future. But if you're trying to follow technology, and we are trying to do that as much as we can, and we're also looking at the human need, then we're trying to figure out how to do this as physically accurate as we can. And one other way of doing it is to join standards organizations. It's not as boring as it sounds. It actually isn't. Because here you actually are talking to people around how you are doing these things and how you can standardize things so you can make ones use many times. We have been part of Kronos since 2017. Mainly because of 3D commerce and GLTF file format. We have been part of starting Metaverse Standards Forum and Alliance for Open USD, and I'll come back to those. But for a retailer not selling silicon or software, joining Kronos, I can tell you, it was scary. Sitting in meetings there with all these tech guys. But we joined, and we saw that we could make good in that. And we also joined as promoter members together with these guys. We are sitting on the board. And as you can see on the logos there, we are really sticking out. But it's quite fun, to be honest. And I think we are doing some good. During this time, we're also being part of starting or promoting to start Metaverse Standards Forum. I just want to note the yellow marked thing here is that it does not create any standards. People are mixing this up. It's a place where leading standard organizations, companies cooperate. It's a thing that I've never seen anywhere else. So if you don't have time or don't feel that you would like to be in on standards, join this and listen in. You will learn so much of where the industry is going. We fell in love in USD already in 2016, personally, definitely myself. But then we have been lobbying for many years now that this needs to become a standard. It needs a standardization body. And when they approached us to start this last summer, we joined immediately. So we are one of the members here joining this, and we really, really like USD. And we hope that that can be a non-proprietary, I almost can't say that word, non-proprietary standard that we can save our high-res original objects in. So we don't have to have that in something that somebody else's own. IKEA is really interested in the surface appearance, how that looks. And that's where we are spending a lot of our time. So we have been playing with Material X for a few years now, and we are hoping that the Alliance for USD will use this as a base for material definition. That would be nice. We would love that. And this is taken from the IKEA Stråla editor, so we made our own editor for Material X to be able to see it fully rendered in the same editor. And here I think that's where we can help the industry, because we are really picky about our products looking the way they do in real life. And we hope if we can manage to make this open source, we would love to. Now I would like to take you on a little journey. It's a personal turning point. It happened the 4th of December 2014 at 1:36 p.m. Pacific time. I was stuck into a room in Seattle at Valve, and this was the room, and then they pointed at the floor and told me, please put this on. And I was a little bit scared. But that was the first time I could walk around on the other side of the screen for 2 hours without getting motion sick, and I get motion sick very easily. That's not a good treat when you're working in this industry. And it was awesome. It was really, really, really cool. I never thought I would feel the feelings I had when I was walking around those 2 hours. The graphics wasn't great, but they were really happy lending us a hardware already in January 2015. And if you know your history, this didn't become public until 2016. And we were using it to look at chairs a lot. And we looked at them in real life and in this, and we couldn't see a big difference. That was really, really cool. We also started to see that this will probably work, size-wise, color-wise, everything. And we also started to feel that there is something going on here that fools the brain. And it got me super interested in learning more about the human brain, the neurons, the way we interpret the images we get into our eyes, and how that really works in there. And if you look at this, this is the way I was taught in school, that the eye is like a camera, and that's it. But that's not true at all. Not true at all. And I would like to show you 2 examples, and you might have seen this in the past. If you take the left one there, you have the A and the B square. You probably, as normal people, see these 2 squares as different color intensity. I would say that you actually get, in your back of your brain, you have changed those color intensities to make sense of the image. This is based on your data, the data or training data for your neurons, to use current language, that has been burned into your training, that must happen if you have the shadow there. Because they are actually the same color. It's you seeing a shadow that makes this happen. The same thing goes for the right thing there. You have an edge here in the middle. That edge looks like the top part is in the sun, the lower part is in the shadow. That means that your brain is changing the input to make the lower part lighter than the top. But it's not. So your brain is changing what you see to make sense of it, to get a 3-dimensional thing in your brain. Another thing we also figured out very fast is that you're only looking into the world at about 2 degrees with high resolution. It goes super fast down to 6 pixels per degree. It's about 60 pixels per degree in the high res. And high res, 2 degrees. If you take your arms out, straight out like this, put your thumbs together, your thumbnails, that's about 2 degrees. That's where you have high resolution. The rest of the things that happen is actually filled in when you're looking around. So you get updates on this small little thing, but then you get everything else is filled in by your brain. You actually have a blind spot in each eye. About 15 degrees out for that eye, and 15 degrees out for that eye. And that's filled in automatically, like a healing brush tool, by your brain. Otherwise, you would have felt like you have 2 black spots, and you don't see that. So you're looking out in the world with high resolution like this, and the rest is filled in by your brain. It actually becomes like a cursor. So you can see where people are looking, and you can use this. And of course, the newer headsets are using that. But that means that the only place where it's a three-dimensional thing is in your brain. Everything else is two-dimensional or only small portions of data that you get. The only place you have a 3D thing is in your brain. That means that your brain is a 3D reconstruction engine. And up to now, a company like us and every company who sells products have been able to show this by showing pictures and you deducing from the shadows you see, from the lighting you see on that, you are building a three-dimensional representation in your brain and figuring out if you're going to buy it or not. But what if we can give you a 3D thing directly? What we think this will do is giving you something that gives you can understand what it is with lower cognitive load. And this is what we're preparing for at IKEA, the future of spatial computing. So the history we stand on is this. We have done this for many years. We know what 3D is. And I won't go to do any big predictions about the future, more than it will be big and fast, bigger and faster. And what we are talking about is really going from these computers, stationary, to the mobile was a big thing. Definitely was a big thing. But the input and output from those smartphones was approximately the same as the things that you had on the stationary computers. Yeah, I know. The newer smartphones knows a little bit about the space, if you wanted to. But I think going to the next step, where the devices we have understand the three-dimensional space and can give data back into that space, is a really interesting thing. Because if you can have that spatial device, you can add a virtual product. We can put that in a space where your home space, so we know where the doors and windows and power outlets and all those things are. We could add things that is not only the visual cortex information. We can add another human there, either in the same space with another device or at another geographical place and get them to that space. We will be able to interact with that thing, lift it up, look at it together, maybe even touch it, like Yo was talking about in the talk before me, and go into microscopic scale, maybe doing cut-throughs, maybe even go to the forest where the wood for that leg was growing up, if we want to. Things that we have been wanting to do for many, many years. And this is what we called spatial computing when we started this in 2017. So we started what we call Spatial Computing Lab. And to be dividing up the problem for us at IKEA, we set up these 9 areas. Rooms. How do you define a room? How do you define products and how they interact with rooms and themselves? How do you do simulation of products, like how do they behave in light or how they fold over each other? You have room understanding, how to understand a space, recreate or redesign that space. Sound, you have experience as someone else. That's experience the same space, but as a person who is longer or shorter or visually impaired or in a wheelchair or something like that. How do you share that experience with people? And then touch and even smell. So if you look at these, you go from the left to the right, you see that they're harder and harder to do. And I would love to show you quests that we are doing. We call our projects quests. We have done over 350 of them now, the last 7 years. But I can't show you a lot of those because they're a secret. But I can show you 2 of them. And let's see if that works here. On the upper left, you have a small little test, a quest we did, trying to move a virtual sofa through a corridor and interact with it and see if you actually could move the sofa from that space to the other space. And it's really hard. It's hard in real life, too. On the lower right, you see the first attempts of you working together in with the same AR planning, but with several different people. These are more than 4 years old, but that's what I'm allowed to show you. I can't show you more than that. Going back to these, I would like to talk about something that I think we can contribute and maybe even help out doing, is the things around room understanding. Because companies like us are sitting on a gold mine. We are sitting on the possibility to make synthetic training data. And we know it, so it's not a secret. The things that we can do is go from these advertising images to deep learning training data. The only thing is needed is adding annotations. And as we are doing it in 3D, we can do permutations of things pretty fast. And as I showed before, we are pretty good at rendering, so we know how to do that. So taking something like this and making a movement in it, walking around in it, we already have it in 3D, so we can do those things. And if you have been working with training data, you know that training data needs annotation, and that's a pain if you're taking it from real world. But if you're taking them from 3D, we'll actually get it for free down to pixels. So we know what's under each pixel at each frame, if we want to do that. Then, of course, different training situations needs different kind of input, but if you just tell what we would like to have, then you can do that. So, why am I here talking to you? We don't sell hardware or software or services. We employ some people sometimes, so if you want to work with us, come and work with us. But my main reason to be here is to put our problems into your brilliant heads. That's my real reason to be here. Because we want to connect and collaborate with any one of you enabling these new technologies. Because in the end, we want to be where the customers are, in their home. We want to use technology to transfer information with as low cognitive load as possible. That's the main goal. It's not really computer graphics. The main goal is to transfer with as low cognitive load as possible. And we want to show our offer of well-designed functional home furnishing products in your living situation. And the IKEA vision is to make a better everyday life for the many people. But we will not build the base technology and the hardware enabling all of this. And the only thing we want to be is best at using this at scale, as smart as possible. That's what we want to do. So reach out to us. And I just want to end with what our founder always said. Det mesta är ännu ogjort, underbara framtid. That's Swedish for most things still remains to be done, a glorious future. Thank you so much for having me here.